Hello and welcome. In this video, we're going to talk a little bit about printing debug text to the screen from the C++ side and making it a little bit easier so that it doesn't require so much coding, so much typing, just to get some text to print to the screen. Now, if you do this from blueprints, it's pretty easy. So I have this third-person template project here. It's basically a freshly created project. I haven't added anything to it. And if I open the third-person character, it doesn't take much to print some text to the screen. I can drag off of begin play and type print and get this print string node, and if I go ahead and play the game, you'll see that it prints to the string to the screen and it stays for a couple seconds. So that's pretty easy. So how can we get that basically that same result from C++ with relatively the same amount of effort? And what I mean by that is, what if we could just type print and say hello and get this this text to print to the screen without having to do anything more than just type print hello like this. So if I go ahead and go back and hit play, you'll see there I have hello printed to the screen. So you can see that I've created this print macro to make things a little bit easier for me. And I've also created some other macros to give us more parameters so that we can do things like change the color, the key, and we'll get into what keys are shortly, and so on. So let's go ahead and dig in and get started. If we go into our C++ file here I have the .h and .cpp file for our character. It's called YouTube examples character, and all of this stuff is just here by default because it's built in when you create a template project, third-person template project. And so what I want is a begin play function. So I can go ahead and add that into the protected section here under setup player input component. It's going to be virtual, it's going to be void, it's going to be begin play without any inputs, and it's going to be override. Now, because I'd like to do some work with the tick function, I'd like to add that as well. So it's going to be virtual void tick. This one has a float called delta time as its input, and it's going to be an override as well. Now we can go ahead and implement these, and I'm going to put them under setup player input component in the CPP file. So here's setup player input component. I'm going to go ahead and place them here. Now, if you have any experience with C++ and Unreal Engine, you'll know that you don't need the virtual and you don't need the overrides. You're going to give these functions their own bodies, and we need to make sure the name is fully qualified with the class name and the double colons at the beginning, and we're going to want to call the super version of these functions. So we've got super begin play, and we've got the super version of tick. And if you don't know about these, they basically call the parent version because this YouTube examples character is based on the character class, and so the parent version is going to need to be called because there may be code at any point in developing that needs to be called on the parent version, unless of course you know you don't want it to be, then you don't have to call super. So anyways, we would like to print some text to the screen just like we did in the blueprint when we used the print string node. And to do that, you have access to a variable called gengine. So if we type if gengine and make an if statement, if you hover over gengine, you'll see that it's a uengine pointer, and it says global engine pointer. It can be 0, so don't use without checking. That's why I checked it right away. And gengine has functions, one of which is add on-screen debug message. Already it's more printing than just typing print in blueprints and getting a print screen node. And we'll see here that it requires quite a bit of input parameters in order to print this text to the screen. So what we need to do is fill this out. Now the first thing is a int32, and it's the key. So we'll explain what the key is, but for now let's just fill this out and get it working, and then we'll come back to what the key is. For now we can type in we can type in the value for the key, which for now we're going to use -1, and I'm going to explain to you very shortly why we're using -1 for the key. Next, we have time to display. Now, if you want 2 seconds, we can type 2.f to give it a float. Next is an fcolor. So an fcolor is a struct that exists in Unreal Engine, and it contains already a whole bunch of colors. For example, if we want cyan, we can pick cyan, and that way we can pass that in, and our message will be in the color cyan. Next is a debug message, and it's expecting an f string. Now, if you want, you can just type f string to create an f string, and inside you can initialize this f string with our message, so we can type hello. Now, next we have a Boolean, and it says newer on top. Now, this is asking if you print multiple text strings to the screen, do you want the newer ones to appear on top or below the previous ones? And it's by default set to true. So if we wanted, we don't have to pass in anything else, because everything else in the input parameter list has default values. So what we can do is we can skip the rest of these, because by default newer on top is true, and if you really wanted to, you can set it to false. But for now, let's just get this working, and let's leave it at that. So as you can see, all of this typing already is much more work than what I had to do in Blueprints, which was drag off, type print, and select print string. I mean, that's much quicker than the C++ version. So very soon we're going to learn how to create a shortcut that allows us to type less code in order to get the same effect. But for now, let's test this out. So I'm going to go ahead and compile this code, and we're going to see the results of this in action. So we've compiled. We can go back into the engine and hit play, and you'll see we have hello printed to the screen. Now, this is not just to show you that there's nothing in Blueprints causing this. This is our C++ code that is printing hello to the screen in cyan for 2 seconds. Okay, so that's great, but like I said, it's quite a lot of typing just to print hello to the screen. So this might discourage you as a C++ developer, because you don't want to have to type all this every time. And so this brings us to the next topic of the video, which is how do we get a shortcut for this? And so what I'd like to do is create a macro that is defined by having this, and that way we can just simply use that macro instead of typing all this. Now, what I'd like to do is create a new header file to have that macro in there, because if we created a macro here in the character file, it wouldn't be available in any other classes, and so we would then have to go and recreate that macro in the other classes that we would want to use it in. But if we create a header file that contains the macro, then all you'd need to do is include that header file wherever you would like to use it. So let's do that. Let's create our own header file, and the way you do that is you come over to the Solution Explorer here, and you find your folder where that contains all of this code. So we have our YouTube examples character, among others, and that's going to be here. What I basically have here is I have my games folder and my YouTube examples. That's the name of my project. I named it YouTube examples. And here in YouTube examples, I have the source folder, and in the source folder I've got another YouTube examples folder, and then I've got all of the files here, including YouTube examples character.h and so on. What I can do is create a new header file here. So what I can do is on the YouTube examples, this is the project name, I can right click and I can click add, and I can select new item. You can also use Control-Shift-A as the shortcut for that, and Visual Studio will allow me to create a new file, and I can select header file. Now for a header file, I need to give it a name, and because I'd like to create some macros in here that make it easy to print debug text to the screen, why don't I call this print strings. .h. And the next thing we need to make sure is that we put this in the correct folder, right? I want this, I'm going to close that for a second. We'll open it again when we actually create the header file. So we're not creating the header file yet, but I just want to show you the path that our YouTube examples character.h and associated C++ files are, and that's here in this YouTube examples folder. Now if I click on the .h file for YouTube examples character, for example, I can come down here into this properties tab and I can see the full path here. Now I'm going to bring it into view, and on my computer it's on my D drive, and I have Unreal Engine 4, YouTube examples, source, YouTube examples character.h. So it's kind of a lot, but if we remember, it's Unreal Engine 4 and so on, I can put my new header file in this same folder, YouTube examples, as my YouTube examples character.h. Now if I do that, I'll have access to things like the G engine, which we need, remember, because we needed to access this G engine, right, in order to print text to the screen. So let's go ahead and create a new header file. And remember, let's take a look at this one more time. It's in Unreal Engine 4. That's where I have my project. YouTube examples, source, YouTube examples. All right. So let's go ahead and right click and add. We can even right click here on YouTube examples and add new item. And you'll see here that if we take a look at this, it says Unreal Engine 4 YouTube examples intermediate project files. Now that's not where we want it. Remember we wanted to, let's click browse and find it here. We had Unreal Engine 4, we had let's see, YouTube examples, and we wanted it to be in the source folder. So source and YouTube examples. This is where we want our .h file to be. So we'll select that folder. And remember, we want this to be a header file, and we're going to call this print strings. Print strings.h. So if we click add, now we have this new print strings.h, and Visual Studio will nicely give us a pragma once macro preprocessor directive here, which if you don't know, it essentially prevents this header from being included twice anywhere. So if I accidentally included it twice, pragma once will prevent it from actually being included twice somewhere. And you'll see over here in our source folder and YouTube examples, well, we should now have print strings.h, and so that's exactly what we want. Okay, so we're ready to make our macro for our print strings. Now, because we put this in here in the folder along with our other associated files, we now will have access to the G engine variable, right? So we can now create a macro that accesses this. So what I'd like to do first is define a new macro called print, because if we could just simply type print instead of all this, for example, if I wanted to print debug text to the screen, if I could say something like print hello, like that, that would save me a whole lot of time and make this a lot easier to print debug text to the screen. So I'm going to go ahead and define a macro called print in our print strings.h file. So to define a macro, all you need to do is do #define and print. And if it's going to be a function type macro, you'll need it to have some parentheses here, and you're going to just add an identifier. It's kind of like an input parameter, but you don't need to specify the type, unlike a function in C++. So we can just say text. And what this does is it defines the print macro and says, okay, the print macro takes one parameter, and then directly after it, you simply define what it's going to do. And what we're going to define on one single line is the following. We're going to say if gEngine, and then we're going to say gEngine add on-screen debug message. And then we can simply call this function. Now, for now, I'm not, again, I said I would explain what the key is, but for now we're going to add -1 for that key parameter. And we're going to use 2.f for the duration, we're going to use fcolor, and let's use white. Fcolor has a white property. And then we can just add the text. Now, what I'd like to do is just simply use the text macro. This makes sure that this is just passing in a text string that is in Unicode. And I can simply use text, because if we assume whenever we call the print macro, if we pass in a string literal, which basically is just a string surrounded by quotes, then whatever gets passed into text will get passed into the text macro here, and that should work. Now you could use, remember what we used was an F string here, but we could have easily just used a text macro as well, so that would also work. That is valid to pass into this. So we're going to use the text macro. And the next one, remember the next parameter was newer on top, right? And if we don't want newer on top, then we can just by default pass in false for this. So this is all we need to define the print text macro. I'm going to save that, and now we have this printstrings.h file, which defines a print macro, and that takes a single string literal, and it calls this add on screen debug message. So if we go back to YouTube examples character.cpp, we can include printstrings.h up at the very top. So I'm going to go ahead and include print strings.h, and you'll see before I finish typing, IntelliSense already recognizes that we have printstrings.h here in our folder, so we can go ahead and select that. So now we have printstrings.h, and if we go back to the begin play, rather than using all of this text, we can delete that and simply say print and pass in hello, and you'll see that print is automatically purple because we defined it as a macro here. So it recognizes that the macro called print exists, and we can pass in hello. Now, what this is basically, a macro is a little bit different than a function. What it does is when we compile, the compiler will say, okay, this is a macro. Let's go look at what the macro is defined as. Oh, it's defined as this, and it literally takes this these lines of code, this line of code here, and replaces this with this. So it replaces the macro with the actual code here. So this is sort of like an alias for the function call. So it's kind of a shorthand, it's kind of a shortcut that we can use. So let's go ahead and go back into the editor and press play, and you'll see now we have hello printed to the screen, and it's white, and it shows up for 2 seconds, just like we wanted. So that's pretty simple, right? That's an easier way than having to say if gengine, then gengine, add on-screen debug message. You don't have to pass all those in. Now, if you wanted to, you could pass those different parameters in. Say you want a different duration, you want a different color, things like that. That's fine. But if you know all you want to do is print some white text to the screen and that's it, well then now you have this macro. So pretty simple, right? But now let's talk about that key I was talking about. Now I mentioned this key, this first parameter is a key. What does that mean? Well, we can define another macro here that takes another parameter for the key. So let's go ahead and define. Let's say pound define, and let's call this one print_k, and print k will take a key for its first parameter and then text for the second. And the reason is because we want to be able to pass in anything for our key. Print just uses -1, but what if we want to use something else for our key? So let's define this, and then we'll talk more about this key. So this is going to say if gengine, and we're going to say gengine, and we're going to call the same function, add on screen debug message. And instead of a -1, we're not going to hard code it, we're just going to pass in key. And next, for the duration, we can hard code 2.f. For the color, we can say fcolor white. And for the text, we're going to add a text, and into text we're going to pass in our input parameter, which was simply text. Okay, so this is essentially the same thing as print, but print k takes a key. So let's go ahead and print using a key. Now, what is this key parameter anyway? In print, key is -1. And if key is -1, that's this very special option for the key parameter. And if you have multiple add on-screen debug functions called, for example, if in begin play we printed hello, say about 10 times, then what happens is because each of these have a key of -1, what we will get as a result is all of these will be printed to the screen, and the newer ones will be printed below the older ones, because in add on-screen debug message, the default for the newer on top equals true. We passed in false for this, so newer messages will be below older messages. Now, just to prove this, why don't we say hello 1 for the first, hello 2 for the second, 3 for the third, and so on. So I'm going to go ahead and number these. This way we will know exactly which of these function calls will be which once we print them to the screen. Okay, so we got 8 here, that's enough. Now, newer on top is false, right? We're passing in false by default here. So, which means newer messages will be on bottom. So let's see this in action. Let's go ahead and hit play, and you'll see the newer ones are on the bottom. So the first one was hello 1, it's printed to the screen, and then the next one is called after, that's hello 2, and it's put on bottom. Okay, so that's what the newer on top variable does. Now, because all of these have a key of -1, you will see them all on the screen at the same time. Newer ones do not push older ones out of the screen. But if we use a key of anything other than -1, then all messages that are in the same key will push one another out as they arrive. So what does that mean? Well, let's change these to say print_k. So let's call print key, and let's give them a key of +1 instead of -1. So here we have hello 1. Let's go ahead and put the second into hello 2. And I don't need the rest of these. I can prove the point simply by calling print k twice. Now, if I call print k twice and both of them are using a key of 1, what's going to happen is first the first print k will print hello 1 to the screen, and then directly after that print k will print hello 2 to the screen, and because they both have a key of 1, hello 2 will push hello 1 off of the screen. It will move it and replace it. So here hello 2 is on the screen. Now this all happened in the space of a single frame, so you never actually got to see hello 1. So that's what happens when they are both in the same key. But if I put the second call into another key, so say 2, then what's going to happen here is because printing hello 2 will put it on a different key than printing hello 1, they will both be able to exist on the screen at the same time. So let's try this out, and you'll see now because they're in different keys, they can both exist at the same time on the screen. Now we will see the usefulness of this when we start printing things in, say, the tick function, which will happen every frame, because as it stands right now, if we just print something to the screen every frame in the tick function, and if every frame each of these is in the same key, we'll only ever get 1, but if we use -1 for the key, so if we just said a -1 here, or the same effect would be just using print, that would also put it in the key of -1. What this will do is, because all of the print strings that are happening every frame are in -1, they will not replace one another, and you will spam the screen. So that's where print k comes in handy, because if these were all in a key that were not -1, they would not replace one another, or they would replace one another, and we will see that in action very soon. What I'd like to do now is be able to print variables to the screen. I would like to format a print macro to be able to pass in more variables. For example, what if I wanted to print the value of delta time to the screen? Like if I wanted to say delta time and then use, say, an escape sequence and then print delta time to the screen. Now, this doesn't work because our print macro only takes a single parameter, but it would be nice to be able to do this where this %f symbol will be replaced by the value for delta time. That way, every tick we could print delta time to the screen. So how do we do that? Well, let's go back to our printstrings.h and let's define one. And to do that, we're going to need to make a special type of macro that can take a variable number of parameters. Sometimes these are called variadic macros because the number of parameters is the variable. And to be able to do that, it's actually pretty easy. So let's do pound define, and what I'd like to call this one is printf. So printf, the F stands for format because we're going to format a string that we print to the screen, and that format will be a string that contains some number of other values, for example, the delta time value. So printf will take two parameters. First will be format. So format will be the string that is passed in, and we're calling it format because it's going to be of the form of a string literal. For example, we'll say delta time, but it's going to contain these special characters. And if you're not familiar with these, this is a property of C++ that when you have a formatted string, if you have for example, %f, then followed by a float value such as delta time, then whatever the value of this, which is a float, whatever that value is, this %f will be replaced with that value in the string. And we're going to see this in action. So format is the formatted string is the first parameter. But then next we want the actual values with which we will replace those special characters like the %f. Now this could be any number of parameters, and for a variable number of parameters in a macro, we use the ellipsis. This is a 3 periods or 3 dots. That will be replaced with our variable number of arguments. So let's define this. So we're going to say if gengine, just like the others, and we're going to call gengine, and it's going to be add on screen debug message. And what we're going to do is we're going to put this into the key of -1. And if it's put into the key of -1, then it's not going to replace the previous message that may still be on the screen. So this is going to be more like the print function in that multiple calls to this, which send text to the screen, they will not replace one another. We can potentially spam the screen if we're calling this in tick, but that's okay. We're just going to do it like this for now. We're going to use a 2.f 2-second duration for this, and we're going to make this an f color of white. And now we want our string. Now we're going to use an f string for this. And the reason is because f string actually has a static function called printf. And you may think that that's, looks kind of funny that it's called printf because we're calling this macro printf. That's not a coincidence. Printf is commonly used in many different languages for formatted strings. F string has the static function printf, which allows you to format a string using values such as float values, integer values, or what have you, and it will create a string using those values. So for this, we're using the printf function that belongs to f string. Now printf takes first a string, and we're going to do text, and we're going to pass in format. So the text macro takes a string literal. We're using the string literal format, which we had passed in here for our printf macro. So printf takes the text, right? And then it takes the arguments. Now, that's what's going to be passed in here. So whenever we call this, we're going to do the string literal followed by a comma separated list of values that are going to be used for that formatted string. And it would be nice if we could just say ... right? But there's a special identifier in C++ that is used for variadic macros, and it's kind of strange looking, but it's a double £, followed by a double underscore, followed by capital VA underscore capital args double underscore. I know that's kind of a lot, and it looks kind of strange, but this is a special identifier for variadic macros. And what it means is that whenever you call printf, whatever you pass in here, which can be a variable number of parameters, a comma separated list of parameters, whatever is passed in here will be inserted here. So whenever this function gets called, if you have, say, 1, 2, or 3 or more parameters passed in, those will be put in here. It will be, VA args will be replaced by whatever's passed in here. So this, you can think of it as a variable number of arguments, right? A variable, VA, variable, number, right? The number sign, args, arguments. So variable number of arguments. It can be any number of arguments. So that's what VA args is. And so that is what we're passing in for the string. We're passing in this call to the static function that belongs to the fstring struct, and it takes a couple of parameters. One is the text string, and the next is the comma separated list of values that will be used to format the string. Okay, so we've got that, and then finally add on-screen debug message. It takes that Boolean, which will be set to true by default, but I'm going to set it to false. So I'm going to pass false in there. And there we have our printf macro. So how can we use this? Well, what we can do is we can go back to begin play here, and we can call printf. And what it's going to do is going to take a text string, and I'm going to say calling printf with the value, and I'm going to use a float. And well, let's say with the values, right? And let's use a float. Let's use an integer. And by the way, the symbol for formatting a string with an integer is D. I think of D as like a discrete value because integers are discrete, you know, 1, 2, and 3, and so on. And let's also use a string. Let's do %sign string. And I'm teaching you here how these formatted strings work. Is basically you've got the string literal, and in the string literal you've got any number of these special characters here. And if you have 3 of them, then you must follow this string by 3 values, and they have to be in the order of the characters here. And the first one must be a float, the second one must be a integer, and the third must be a string. And let's create these up here. Let's say float pi equals 3.14f. Let's do float, oh sorry, it's going to be an integer. Let's make it an int 32, and let's call this I, and let's give it a value of, say, 7. And then finally let's do f string, and let's say let's call this s, and let's give it a value of text. Actually, what we can do is use the we can use this method of initializing it, and let's say text, and let's call this the string. So we've got a string, and what we can follow this by here is we can simply pass in the variable, the number of parameters, so pi, I, and s. Okay, so what we're doing is we're calling printf, we're passing in the string literal for the format. And S. Now, one thing you need to know about this is the fstring format function, or printf function. If you're formatting a string that contains this S, you can't simply pass in an f string. It has to be a string literal or equivalent, which is basically what things like this are. It's a series of a series of characters surrounded by double quotes. So an f string is not a string literal. However, it has overloaded the asterisk operator, and what you can do is it simply looks like this. It looks a little strange. It looks like you're dereferencing a pointer, but that's not what you're doing. If you have an f string variable, if you use the operator like this, what this returns is a string literal. It's basically a array of t-chars, t or t-chars if you prefer. A t-char is simply a equivalent to a character. Without going into too much detail, this is the equivalent of a string literal. So whenever you call f strings printf and you pass in a variable number of arguments, if one of those is a string, make sure it's a string literal. And if it's a f string object, you can get a string literal of that by using this operator. Okay, so what this is going to do is it's going to print this to the screen, and it's going to replace the %f with the value we passed in here, which should be 3.14. It's going to replace %d with the value here, which is the integer 7, and it's going to replace %s with the string here, which is the string. So if we go back and test this out, hit play, you'll see calling printf with the values, and of course it only lasts 2 seconds, which is a little bit inconvenient, but you could change that if you want to. But we got 3.14, 7, and the string. I'm going to pause it here so we can see. Actually, when you pause it, it doesn't actually pause the print strings, but that's fine. Okay, so what I'm going to do is we're going to go back and take a look at the printf function, and what if we would like to put these in a different key? Because as it stands, if these are in the key of -1 like they are, if I say copy this and put it in the tick function, then what's going to happen? Well, printf is printing this formatted string to the screen in the key of -1, which means they won't replace one another. They will simply spam the screen. So we want to be able to put these in a different key other than -1. So let's create a new macro that takes a key. So let's go back, let's go to printstrings.h, and let's do pound define, and this will be, let's call this printf underscore k being the key. So this is going to take the key, it's going to take the formatted string, call that format, and then it'll take the variable number of parameters, which is we're going to use the ellipsis for that. And so we're going to say if gengine add on screen debug message, and we need to pass in the key. So first we're going to pass in key, then we're going to pass in our duration to .f for 2 seconds, our f color, and our formatted string, and that's going to be essentially the f string static function printf, which takes the string, which is going to be text with format passed in, followed by this vargs, variable number of arguments identifier. We're going to pass that one in. Right, and then we don't need to pass in false for newer on top, the Boolean for newer on top. Why? Because it's not going to ever have multiple strings in this key passed in at the same time on the screen. They're going to push each other out of the screen, so newer on top doesn't even really matter. So let's test out printf k, and we're going to test it out here in the tick function. So what I'm going to do is I'm going to go ahead and delete these, and I'm going to say printf underscore k, and let's put these all in a non-1 key. Let's put them in, say, 1, and let's use for our string, let's do delta time, and we're going to say %f for a float, and then finally we're going to pass in the value of delta time. So we got our key, we got our string, our formatted string, and then we got the value with which to replace our %f, and that's going to be delta time. Since these are all going to be in the key of 1, then we'll only ever see one at a time. We're not going to spam the screen, and newer ones will replace older ones. So let's go back and test this out and hit play, and here we have it. Every frame we're printing delta time to the screen, and every time, every frame, delta time is different, which is why you see this value changing. It's 0.008334 one frame, and then the next it'll be 0.00833. So it changes, and if I run around and do things, well, running around and doing things doesn't really take that much computational power, so it's not really going to increase that delta time very much. But in a game with a lot of complicated stuff, that delta time is going to vary quite a bit. So that is the value of having a print with the key, right? We can specify the key, and if we wanted to, we can have multiple versions of these. We can do printf key and put something in a different key, and we can say maybe delta time times 2, I don't know, and then for delta time, or for the float passed in, we can pass in delta time times 2, for example. And this should just give you delta time times 2, basically the double value of delta time, but it's in a different key, so it's not going to replace the other log. So now we have both of them printed to the screen at the same time. And you'll see, you know, I don't know why you'd ever want delta time times 2. Maybe delta time times 100 would be valuable. You know, if you wanted to see that in, or times 1,000 maybe, you can, because this is in seconds. If you multiply it by 1,000, well, then you've got milliseconds, right? Okay, so that is how to create a printf k, right? And printf k is, you've seen the value of that, and of course all of these are we've hard-coded many of these variables, and so what we're doing is we're taking away the ability to change the color, to change the duration and things like that, which if all you care about is printing something to the screen and you don't really want to have to specify all that, it saves you time when you're developing. You know, if all you want to be able to do is print and, you know, type a string, and that's all you want to have to do to get text to the screen, then boom, that's why these are so valuable. And the value of creating your own header file to put these in means that you can include print strings in any other class. For example, we can go to, say, the game mode, and we can do a include of print string, and then, you know, whatever. I mean, the game mode is maybe not one of the classes you would use for this, but you can create any other class and include printstrings.h, and then you have access to these new macros. Now, just to show you that it's pretty easy to create various versions of these, we can go ahead and copy these four, and we can go down and paste them, and let's create some new ones. If you want, say, yellow messages to the screen, like yellow is typically associated with warnings, we can create a new version of this called warn, and instead of fcolor white, we can use yellow. And we can create a new version of the print k with yellow, and we can call this warn k. And of course we can change this to yellow. Oops, yellow. We can call this one warn f, and change this one to yellow. And we can call this warn fk, and change this to yellow as well. And as you can see, you can create any number of these. For example, you may want to create one where you can specify the color. You can call this print C, for example. And print C can be the same thing as print. So let's call this print C, and then this can take two parameters like text, color. And you can simply have, instead of F color white, you can use color. And of course we need to use define, like that. So now we have print C for color, and we can call this, if we want, here, say in begin play, I'm going to go ahead and comment out these, and I'm going to say print C, and we're going to say hello. And for the color, we can say F color. It's got to be an F color, and we can use, say, black. So this is essentially the same as printf, only now you've got a version that takes a color, and you can print it any color you want. So you can make any number of these that you want, and then there it is, hello. It's a little hard to see, but you can see it there. So that pretty much concludes this video. I just wanted to show you a way to create some macros to give you a shortcut to printing debug text to the screen. So now you know how to do it. Now you understand this key parameter as well, which allows you to essentially decide whether or not you want to spam the screen or replace older messages with newer ones if they're in the same key. We also learned how to create a formatted string, and this f string printf, let's just take a look at this again outside of the context of using a variadic macro. If we want to format a string, we can do so. So here I'm in begin play. I'm going to create an f string and call this formatted, and I'm going to initialize it with f strings static function printf, and this is going to say pi equals, and I'm going to use the %f, and then I'm going to pass in 3.14159f. So essentially what this does, oh, and I'm going to pass this in using the text macro, like so. And what this does is it formats a string. It says pi equals, and it's going to pass that in. So this gives us an f string. Now if we want to, say, use printf, and we can give this the string, which will say the value of, and then followed by the value of %s, we're going to pass a string in, and then followed by the asterisk formatted. Then essentially what we're doing is we're formatting a string again. So we're taking a f string, and this f string, we used f strings printf to format it, and then we're going to pass that in using the asterisk to get our string literal, and then we're going to format another string and say the value of, and so this %s should be replaced by the formatted string, which should say pi equals 3.14159. So if we go back and test this out, we'll see the value of pi equals 3.14159. So actually 3.14159 is incorrect because pi keeps going, and I don't think that next digit is 0, but that's beside the point. So there you have it. That's how you can create some new macros calling this add-on screen debug message function. And really there's no end to the number of these you can make. And now we have this handy printstrings.h file that we can include in any one of our files if we want to use these nice handy shortcuts. So I hope this was helpful. I hope you enjoyed learning a little bit more about the add-on screen debug message, and also how to shorthand that and give yourself some nice little print functions or macros that you can use to print things to the screen. So hopefully that was informative for you. If it was, and if you enjoyed this, please like this video if you would like to. If you want more videos on Unreal Engine and C++ and just interesting things in the future, go ahead and subscribe, and set yourself up for alerts for when I have new videos if you like. Go ahead and do all that. And thanks for watching, and I hope you have a great day. Happy game development.